Good morning, class. Well done on your tests. I finished grading them. I will have them up and your grades up. I definitely was able to give more points back to those who showed the work because what came to my attention is that those who showed work actually would sometimes do the right thing. Um, we may need to talk about distributing negatives and adding negatives together because it seems like a common enough occurrence was that people were having trouble with that. Not all of you, obviously, but some of you were having that trouble. Now, you might have noticed on the test there were some questions that had properties that you weren't sure about, and actually, it's my property. So if property was addition property, subtraction property, or multiplication or division property, equality, will definitely I'll definitely give you a point back at least for that. I do think that because it was those practice problems in Delta Math, it was doable for you to have learned this. So we're going to talk about solving one-step and multi-step questions. One-step equations are going to have one operation that we need to reverse or do the inverse of. So for example, addition, if you have operation addition, the inverse is, if you added 8, the inverse is going to be to subtract 8. If you subtracted 8, the inverse is going to be to add 8. If you multiply 8, the inverse is going to be to divide 8. And if you divided 8, the inverse is going to be multiply 8. Okay, so these are inverse operations. And you should know these. These are something that you covered in math class. Sorry that it's a little bit crooked. I'll try that right. It's straight from now on. Okay, so equivalent equations basically means that two sides of an equal sign are going to be equal. Okay, so what you do to one side, what you do to this side, you must also do to this side. So if you add to this side, you add to this side. If you subtract to this side, you subtract to this side. Divide to this side, you divide to this side. And if you multiply this side, you multiply this side. There is only one exception, but we'll talk about that later, not today. So you don't need to know this one. Okay, addition property equality. Basically, if you have x minus a equals b, okay, then if you add a to both sides, the equation is still equal, okay? Okay, and negative a plus a is going to cancel because they are inverses. So then you're going to get x equals b plus a. So this is addition property. Then subtraction, which is going to follow almost the same idea, almost. So if you have x plus a equals b, then if you have x plus a and you subtract a for both sides, the equation is going to be still equal. Okay, positive a minus a are going to cancel. Okay, so you're going to be left with x equals negative b minus a. Okay, so adding or subtracting the same number is going to still be equal. Okay, this is the addition property of equality. This is subtraction property of equality. Okay, using solving an equation with a subtraction property. So right here, you have x plus 7 equals 4. Then you're going to subtract 7 from both sides. So you're going to get x, because these two will cancel. 4 minus 7, so that will give us negative 3. So x equals negative 3. Okay? And you don't have to check that it's not necessary yet. Okay. We're halfway done with this, so we can definitely go on. Okay. Um, so again, using the addition property of equality, x minus 12, so x minus 12 plus 12 equals 3 plus 12. So negative plus the positive of the same value is going to give us 0. So x equals 3 plus 12, which is 15. So x equals 15. Okay. There's vertical, horizontal. Essentially, you don't need to worry about it. You can do either one. Okay, multiplication property of equality or division property of equality. So we're going to write this here. So we're going to have multiplication. So this property is going to have x divided by a, as long as provided that a does not equal 0. That's just because we can't divide by 0. Not can't, it's not useful. Okay, so you multiply a times x over a equals b times a. Or, so these two cancel because the numerator and denominator have the same value, so you're going to have x, and then this is going to be a, b. Because you could switch the order, and that's commutative, is switching the order. Okay, then division property. So division property is going to have ax equals b, again provided that a is not equal to 0, because if you multiply this, this is not going to be useful. And we're going to then divide both sides by a. Because if a is not 0, we could divide by it. Okay, we divide, this a is cancelled, so then your answer is x equals b over a. Okay? Multiplication property, division property. You guys should be used to these, but just practicing them. So if you have negative 6, x equals 48, this will be using the division property. So we will divide by negative 6, so negatives cancel, so you get x, negative 6 cancel. 48 divided by negative 6 is going to provide us a negative 8, because a negative times a negative is going to be a positive. Okay. Okay, and then if we were to do using the multiplication property of equality, x over 4 is equal to 5. To solve this, we would need to multiply both sides by 4. Canceling this, you get x. 5 times 4 is 20. So our answer is x equals 20. Okay? Okay, that's how we use multiplication and division. But notice, these are whole numbers. Okay, what if we're using a fraction? So actually, a fraction is going to be kind of a combination of both. So if you have a fraction, you will multiply by the reciprocal. Okay? Multiply by the reciprocal. So to cancel out negative 2 over negative 7, you're going to multiply by negative 7 over 2 to both sides. Okay, so you multiply by the reciprocal. That cancels out here, right? So then we get x equals, what's 7 times 2? 7 times 4 is 28 divided by 2. So negative 28 over 2, which would become x equals negative 14. Okay? So we multiply. This is multiply by reciprocal. Okay? This is especially true when you're trying to cancel out a fraction. Okay? Okay, and that should be it for 3.1. There is one last question, so we'll cover that at the start of the next video. Okay, see you in the next